This is Mark Maclaine, and this is a video on completing the square. Now, completing the square is another way of factorising quadratics. Factorising meaning to put brackets in. Instead of doing it into two brackets, however, we do it into this form here, where it is x plus a number, all squared in brackets, plus another number. Now, in order to create this form, the first thing we need to do is half the b value. Now, the b value here is the number in front of the x, or the coefficient of the x. So in this case, it would be 4. We write it in this form here. We write the brackets, so that'll be x plus something all squared plus another number. And in this case, we've halved the b value, which is plus 4. Okay, so it's plus 4. Now, what actually goes on here will be dependent on what's going on in the brackets. So let me quickly explain this. If I expand out the brackets x plus 4 squared, that will give us x plus 4, x plus 4. And if we expand that out, that'll give us x squared plus 4x, and then 4 times x plus 4x, and then plus 4 times 4, which is 16. So in total, will give us x squared plus 8x plus 16. Fine. Now, what we've done in this part here, we have actually formed x squared plus 8 there. So that's the goal. So what we're actually trying to do is we're trying to create this section first. So we're creating the x squared plus the 8x. Okay, so let me just clear off this little box here. So, as I said, we're creating this section, this x squared plus the 8x, which is indeed this part here. The only problem is there's this plus 16 on the end. Now, in order to get rid of that 16, we just then take away 16. Now, what that means is this section here is the same as x squared plus 8. But of course, there is still the plus 3 on the end. So if we simplify this whole thing, what we end up with is x plus 4 all squared minus 13, because negative 16 plus 3 is negative 13. So that is our final factorized form. So essentially, we've completed the square. Now let me have a look at another example here. So say, for example, we want to put x squared plus 12x minus 10 in that form. It'll be x plus a all squared plus a number. So that's the form we're trying to get it into. So what we do is we write x plus something, or it could be minus, but x plus something. Okay, here we go. Now what I do is, just like the last time, I halve the b, and that goes into here. So what we've got is we've got x plus 6, okay, all squared. Now, why have we done the x plus 6? I'll show you. What we're trying to form is we're trying to form this part here, the x squared plus 12x. Okay, so we're trying to create the x squared plus 12x. Well, let's just quickly expand that out. So if I did x plus 6, I would end up with x squared plus 12x plus 36. So I have indeed created the x squared plus 12x. That's fine. The only problem is there is this 36 on the end. So all we have to do is take away that 36, and then we know that this box here is the same as this box here, but don't forget the minus 10 on the end. So the final factorized form into completed the square form would be x plus 6 all squared minus 46 here. Now, just a quick note about completing the square. One of the uses of it is that it means we can actually find the turning point of a curve. Now, what do I mean by turning point of a curve? If you have a normal x squared graph here, okay, so this is my y and this is my x here, and this is my x squared graph, so y equals x squared. We can see that the turning point is at 0, 0. This is the point where it goes from a negative gradient here to a positive one. Okay, but if we then, here we go, have a look at this graph here. If we, instead of that graph, we had y equals x plus 2 all squared, what would then happen is the graph would actually be shifted over to the left this way, and the turning point would actually be at minus 2, 0. Okay, so this one here, the turning point here is 0, 0. And in fact, the completed the square form, actually, as I say, allows us to find this turning point, because if, for example, we drew another graph that was just shifted upwards like this, so it was shifted up by, say, +3, that was 3 higher, the way that could be written is y equals x plus 2 all squared plus 3. You've added a 3. By adding a number outside, it shifts the entire graph up. Now, of course, I'll do more of this in a video on transformation of graphs, but essentially the key here is understanding that this +3 on the end has moved the whole thing up +3. So it's no longer, so this turning point here is no longer at -2, 0, it is at -2, 3. So, again, even if you don't quite understand that, the most important thing to understand here is if you've got your complete the squared form, which is this, whatever the a inside the brackets here is, the negative value of that will be your x coordinate, and whatever the b value on the end here, that will be your y coordinate there. So say, for example, we had the graph of x plus 3 all squared plus 5. The turning point for this would be at the point -3, 5. In the same way, if I had x minus 2 all squared plus 10, the turning point of this one would be at 2, 10.